Green synthesis of titanium dioxide nanoparticles replaces toxic chemical reducing agents and harsh solvents with biological materials like plant extracts, algae, fungi, or bacteria. Active phytochemicals, flavonoids, polyphenols, proteins, and terpenoids act as both reducing agents converting precursor ions to and capping, stabilizing agents preventing nanoparticle agglomeration.
Wash plant leaves, peels, or biomass thoroughly with distilled water. Boil or stir in solvent, typically deionized water, to extract water-soluble biomolecules, then filter the supernatant. Boil or stir in solvent, typically deionized water, to extract water-soluble biomolecules, then filter the supernatant. Mix a titanium precursor solution, such as titanium tetrachloride, titanium tetraisopropoxide, TTIP, with the extract under controlled stirring and temperature, 50 to 80 C.
Maintain the reaction at 50 to 80 degrees Celsius under continuous stirring, pH adjusted to 7 to 9 using sodium hydroxide if necessary. The phytochemicals reduce, hydrolyze the titanium ions into a hydrated oxide precipitate. A color change confirms nanoparticle formation. Centrifuge the solution at high speed, 8,000–12,000 rpm, for 15 minutes. Wash the collected precipitate multiple times with distilled water and ethanol to remove unreacted biomolecules. Wash the collected precipitate multiple times with distilled water and ethanol to remove unreacted biomolecules. Dry the product in an oven at 80 to 100 degrees Celsius. Calcine the dried powder in a muffle furnace at 400 to 600 degrees Celsius for 2 to 4 hours. To burn off residual organic matter and convert the amorphous powder into crystalline text, TO_2, anatase or rutile phase. Breaks down organic pollutants, dyes, and pharmaceutical waste in water treatment under UV, visible light. Disrupts bacterial cell membranes and generates reactive oxygen species to destroy pathogens. Provides high UV blocking capability with enhanced biocompatibility for skin contact.